Hello everyone. Now we are going to discuss about module 3, protocols and modules. First we will discuss about the protocol. Protocol means the set of rules. So to govern the communication between the sender and the receiver, we need protocols. First we have to establish the rules. If you want to communicate from a source to destination, you need a protocol. You need some set of rules to govern, to manage that communication. The protocol is accountable for the following requirements. What are the requirements? A protocol is used to identify or verify the sender and receiver. Protocol is used to manage the common language and grammars between the senders and receiver. Protocol maintains speed and time of delivery between the sender and receiver. The protocols are responsible for sending the confirmation or acknowledgement to the sender. Message delivery option. When a sender wants to deliver the message to the destination or receiver, there are three different types of message delivery options are available: unicast, multicast, broadcast. If the sender wants to deliver a message to a particular device, it will use the unicast method. In unicast method, the communication will be between one sender and one receiver. Second method, multicast. In multicast method, the sender will send the message to a particular system in a group, not to all. So the communication is between one to many but not to all. Broadcast. In broadcast message delivery option, the message will be delivered from one sender to all the receivers in all the systems in the node. So one sender and all will be the receiver. So these are the three different types of message delivery option: unicast, multicast, broadcast. Unicast refers one-to-one communication. Multicast refers one-to-many communication but not all. Broadcast refers one-to-all communication simply. Protocol interaction. If you want to send a message from one system to another system, we need several protocols in a sender machine, also in the receiver machine. Each protocol has its own function and format. Each protocol will delivers a unique functionality. Each protocol has its own responsibility. Each protocol performs different function. Each protocol has different structure and format. If you see, multiple protocols are involved to send a message from the sender to receiver. For example, HTTP protocol, TCP protocol, IP protocol, Ethernet protocol. So we need this many protocols in the sender system to send the message. At the same time, we need the same number of protocols in the receiver system to receive the message. So sending a message and receiving a message is not a single task. It involves multiple protocols. Multiple protocols will handle the message. Right. Now we will discuss the functions of each protocol. First we will take the HTTP protocol. The HTTP protocol is used to govern the communication between the web server and the web client. The HTTP protocol defines the content and format of the message. We go to the second protocol, TCP protocol, that is Transmission Control Protocol. Transmission Control Protocol manages the individual conversation between the sender and the receiver. It provides guaranteed message delivery. That means the TCP protocol in the receiver will send the acknowledgement to the sender. So the sender can ensure whether the message reached the destination or not. TCP protocol is responsible for managing the flow control. At what speed the data should be sent and received is managed by the TCP protocol. Now we come to the Internet protocol. The Internet Protocol is responsible for delivering the message globally from the sender to the receiver. That means if you want to send a message from a local network to remote network, if you want to send a message from your local network to internet, so the Internet Protocol is responsible for delivering the message to the remote network or internet. Ethernet Protocol. The Ethernet Protocol is responsible for delivering the messages within the same network. The Ethernet Protocol delivers the message from one NIC to another NIC card if these two NICs are connected in the same LAN. So TCP IP protocol example. If you see the TCP IP protocol, there are 4 layers are there: application layer, transport layer, internet layer, network access layer. This TCP IP protocol operates at the application layer, transport layer and internet layer. If you see this 4 layers, in each layer it will have a unique protocol. Not the same protocol is available in all the 4 layers. The unique protocols are available in all 4 layers. Application layer protocol. Application layer contains some protocol. Say for example, application layer may contain the HTTP protocol, FTP protocol, SMTP protocol, and then DHCP protocol. So based on the application layer will use the protocol. For example, if the user is using the web browser, he wants to open a web page, then the application layer use the HTTP protocol. Now the user want to send an email, the application layer will use the SMTP protocol. The user want to send a file, the application layer will use the FTP protocol, file transfer protocol. The device, the server wants to assign the IP address to the client, the application layer will use the DHCP protocol. Right. Each layer will use several protocol. All the protocols will provide the unique function. All the protocols are having individual responsibilities and roles. Right. Now we go to the second layer, transport layer. The transport layer contains TCP protocol and UDP protocol. TCP is a connection oriented protocol. UDP is a connectionless protocol. If we compare this TCP and UDP protocol, TCP is reliable, at the same time UDP is faster. TCP will send the acknowledgement, whereas UDP does not send the acknowledgement. TCP is slower, UDP is faster. Okay. Come to the internet protocol. So in the internet layer we have the IP protocol, internet protocol. Right. Come to the next layer, network access layer, the 4th layer. In the 4th layer we have the 2 protocols. One is Ethernet protocol, another one is WLAN protocol. For the wired network, the network access layer will use the Ethernet protocol. For the wireless network, the Ethernet layer, the network access layer will use the wireless LAN protocol. So how many layers are there in this TCP protocol model? 4 layers. What are the 4 layers? Application layer, transport layer, internet layer and network access layer. So what are the protocols used in the application layer? HTTP protocol, FTP protocol, SMTP protocol, many protocols are there. Transport layer, in transport layer we can use TCP protocol, UDP protocol. In the network access layer we can use the Ethernet protocol and WLAN protocol. Why we are using the layered model in the network? What are the benefits of using the layered model? See, understanding how a network operates or how the network function is a difficult task, complex task. It is very difficult to understand. So to make it easy to understand, they developed the network model in terms of layered model, in terms of layers. So the complex concept such as how a network operates can be difficult to explain and understand. For this reason, a layered model is developed and used. There are 2 layered models are there. One is OSI model, one is TCP IP model. What is OSI? Open System Interconnection. It was developed by ISO. The next one is TCP/IP reference model, transmission control protocol, internet protocol, TCP/IP. You can see here the OSI model contains 4 layers, the TCP/IP model contains 4 layers. Now we will discuss about this OSI reference model. OSI reference model contains 7 layers. From the top I will explain: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. The application layer is responsible for establishing the end-to-end communication between the applications in the sender and the receiver, or it contains the protocols used for process-to-process communication. It maintains several protocols, as I said. Presentation layer. The presentation layer is responsible for grammars and the common languages, for managing the common languages and grammars between the senders and the receiver. It provides for common representation of the data transferred between the application layer services. Next, the session layer. The session layer is responsible for creating the session between the sender and the receiver. Before sending the message, first the communication should be established. The session should be established between the sender and the receiver to send and receive the data. So that is done by the session layer. The next one is transport layer. The transport layer defines services to segment. The transport layer receives the message from the session layer, and then it divides the message into smaller pieces called or you can call it as chunks. Later it encapsulates this each smaller message into segment. The segment is called as the transport layer PDU. If you see the transport layer PDU segment, it is having 2 parts: header part, trailer part. In the header part, it stores all the information like port number and other informations of the sender and the receiver. In the body part, it will store a piece of the data. A chunk of data is stored in the body part. The transport layer will forward its PDU, that is segment, to the next layer, network layer. The network layer will receive the PDU from the transport layer, that is, it will receive the segment from the transport layer. Again, it will encapsulate the segment. The network layer encapsulates the transport layer PDU in the form of packet. So the packet is having the header part and trailer part. In the header part of the packet, it adds the IP address of the source and it adds the IP address of the destination. In the body part, it will store the segment. In the body part of the packet, the segment is stored. I hope you understand. Now the network layer forward its PDU, that means packet, to the next layer, that is the data link layer. The data link layer receives the packet from the network layer. After that, it encapsulates the packet in the form of frame. Now the data link layer PDU is known as frames. The frame is having header as well as the body part. In the frame header, we are going to add the source MAC address and the destination MAC address. In the body part of the frame, we are going to store the packet. The data link layer forwards its PDU, that is the frame, to the next layer, physical layer. The physical layer again encapsulates this frames in the form of bits, that means zeros and ones. Then the physical layer will check the type of the transmission medium. If the transmission medium is a wired network, if it is a copper wire, then it converts the bits into electrical signal. If the physical medium is a fiber optic cable, then it converts the bits into light signals. If the transmission medium is wireless, then it converts the bits into radio frequency waves. Now we will discuss the TCP/IP model. TCP/IP model is having only 4 layers: application layer, transport layer, internet layer, and network access layer. So if you see that the responsibilities of these layers are almost same compared to OSI reference model. And in the next slide we are going to compare these 2 models. That time I will explain you clearly. Right, now we are going to compare this OSI model and TCP model. So if you see the OSI model, there are 7 layers are there. In TCP/IP model, only 4 layers are there. if you see the application layer of the TCP model, which is equal to the application layer, presentation layer and session layer of the OSI model. That means the application layer of the TCP IP model will do the function of the application layer, presentation layer and session layer. The application layer in TCP IP model is equal to the application layer, presentation layer and session layer in the OSI model. I hope you understand. Right. So the TCP IP application model, TCP IP model application layer provides the functions of the application layer, presentation and session layer in the OSI model. Right. So this is the major difference I want to tell you. Right. The next thing is the transport layer. The responsibility of the transport layer in TCP IP model and the OSI model are same. Now go to the next layer. The next layer is the internet layer in the TCP IP model, whereas in OSI model we call it as a network layer. Right, the responsibilities are same, no change. Now come to the next layer, network access layer. In TCP IP model, from the top, the fourth layer is the network access layer. The network access layer of the TCP IP model is equivalent to the data link layer and the physical layer. The network access layer in TCP IP model will do the function of the data link layer and physical layer in the OSI model. Right. And now we can ask a question. The application layer in TCP IP model is equivalent to which three layers of the OSI model? So you have to write application layer, presentation layer and session layer. The internet model in the application layer is equivalent to which model in the OSI model? Network layer. The network access layer in the TCP IP model will do the functions of which layers in the OSI model? Data link layer and physical layer. So like this we can make some questions, right? Now protocol data unit. So whenever the application layer receives the data from the user, it forwards the data to the next layer, presentation layer forwards the data to session layer. In all this, if you see the TCP IP model, the application layer PDU is known as the data. The application layer PDU is known as the data. The application layer forwards its PDU to the next layer, that is the transport layer. The transport layer will encapsulate the application layer PDU, and then the name of the transport layer PDU is known as segment. The transport layer forwards the segments to the network layer. Network layer encapsulates the transport layer PDU. The network layer encapsulates the segment and it creates the packets. The network layer forwards its PDU packet to the next layer. Okay, sorry, internet layer will forward it to the next layer. What is that next layer? That is the network access layer. Network access layer encapsulates this packet into frames. Then it encapsulates the frame into bits. Right? I hope you understand this one. So that's it.